So good morning, welcome everyone. It's tremendous to see you all here, and thank you for coming in and spending the day, such a beautiful day, with us. My name is Andrew Smyth. I'm a professor of civil engineering and engineering mechanics, and I'm also the director of the Center for Smart Streetscapes. So welcome all of you. It's really great to see you for this first Innovation Summit here at Columbia. So let me just give you a quick kind of recap of who we are, what we're about, and then why we are having this Innovation Summit. So we're a National Science Foundation Engineering Research Center, and we're specifically what they call a Gen 4, and sometimes you might hear us use the acronym ERC, so Engineering Research Center. These are sort of the crown jewel of the National Science Foundation Engineering Directorate, so it's their largest awards. They're given on a 5-year and then renewable for another 5-year basis. And ours was awarded in September 22, so we're sort of a year and a half into that first 5-year period. So Columbia University is the lead institution, and then we partner with 4 other partner universities, Florida Atlantic, Rutgers University, University of Central Florida, and Lehman College. Here in the Bronx. And so this partnership is very important, and we draw on the strengths of the different partner institutions, and we represent about 35 faculty from different areas: civil engineering, electrical engineering, computer science, the social sciences as well, so planning, public policy. So it's really a big tent, and that's essential in order to solve the kinds of challenges that we are hoping to solve in the street. So our mission is to forge livable, safe, and inclusive communities, so those are the key words for us, and through a variety of technologies. So it's bringing together sort of Smart Cities 2.0 at this hyper-local level. So building applications, we're looking to create a platform that can support applications, and they're built on advancements in edge cloud technology, wireless optical engineering, visual analytics, but other sensing capabilities as well. Privacy preservation and data security is really foundational to our whole approach. And then to integrate social sciences, because engagement with our broad stakeholder base, particularly communities, is extremely important to our sort of initiation of scoping out what applications are needed and how they should be best realized and scaled and rolled out in communities. So our vision, and that's a key part of why this Innovation Summit is critical and why it's great to have all of you here, which is that this is about partnerships. So we, as I showed you, are a partnership of primarily universities as part of the NSF Engineering Research Center Award, but obviously there's a limited amount that academics can do. We can do cutting edge research, but actually to deploy and realize things in the real world, we need to do that through partnerships at government, industry, community, and then working together with us in academia. And so for us, we want to improve life on the streetscape for all. So inclusion, equity are also key themes for us, because we feel that a lot of, let's say, first generation smart cities hasn't always centered around that, and has led to some let's say, suboptimal results, I think, or they're losers, winners and losers is probably the best way to put it. By streetscape, I should maybe address that head on. What we're talking about are the roads, sidewalks, public spaces. Basically, it's the place where the public life, the commercial life, everything intersects in urban centers, and that's an area where we think we can make a tremendous impact. And obviously, cities, we are big fans of cities. They're a big part of the answer to sustainability challenges, global sustainability challenges. Urbanization is only increasing. And so to solve challenges at the street is a key part of our mission. Importantly, and this is probably unusual for engineering research centers, we have a statement of values as well. And primarily, tech should serve the public good. So that is critical to us. Also, this community engagement element serves as the mechanism for direct use inspiration. And so our process is really to begin with engagement with community stakeholders in our various testbed communities. I'll talk about those in a minute. To really define and identify actual needs, as opposed to coming with a hammer and looking for a nail. It's really what are the challenges that are priorities for community stakeholders, and then looking to see whether tech can be part of the solution. And tech is not the solution for everything, and so things have to be co-designed. And also, in order to execute that well and to do that engagement well, technology has to be legible to the public and so to have a meaningful discussion. And so with that also comes workforce training, so that is a key part of an engineering research center or an ERC. So the areas in which we seek to have an impact, this is a busy slide, but maybe if you look at the bottom row, are these 5 thematic application areas. In road safety and traffic efficiency, in public safety realm, for assistive technologies around the future of outdoor work, how technology can support that, and also the monitoring and sensing of hyper-local environments. So looking at technologies that we can bring to life around these 5 thematic areas. And as you'll see and hear in some of the lightning talks today, we're already making progress in some of these areas specifically. This is our research framework and the way that we've organized our research into 5 what we call research thrusts. You might hear these things mentioned. So there's Y-Edge, this is down the bottom left here, which is the wireless, advanced wireless communications coupled with edge computing, and it's basically a way to do very high bandwidth communications, but at low latency, so very, very rapid communications and with little delay so that we can have real-time interactions. Situational awareness is critical, so that's using computer vision, other sensing modalities in order to understand dynamic street scenes, understand context, and then be able to act upon them. Security, privacy, and fairness, the third research thrust, is woven through everything. And so a key advantage, for example, of edge computing is simply that distributed architecture allows for improved privacy preservation. So not everything has to be computed to centralized cloud servers, for example. As you can see, wrapped around all of this is the public interest technology thrust. That's primarily social scientist-driven research thrust, which is about the engagement and getting that true, meaningful feedback and understanding of sensibilities around the technology and wants and desires. Basically, we want to build tech that is ultimately sustainable and accepted by our communities. And finally, Research Thrust 5, which is the applications integration, bringing it all together in order to actually realize a demonstration pilot, for example. Now, as academics, we often do a lot of things in our labs. Each of us has great labs, but in order to really make an impact in this field, we need to bring things out into the real world. We have 5 complementary urban test beds. And you'll hear about these in a presentation later. One in New Brunswick, New Jersey, which is focused primarily on connected vehicle technology. Here in West Harlem, just out the window here, is a Beyond 5G urban wireless state-of-the-art communications test bed. And in West Palm Beach, a pedestrian micromobility intelligence test bed. These are different. The settings are different, as you're going to hear, and that's important because this is sponsored by the federal government, and they want us to make an impact on all kinds of urban communities, so not just one that's like New York City. So these are again, different urban settings with different challenges, but also with different technological strengths. So finally, why are we holding this summit? This is sort of a representation of the core mission of any engineering research center. So this is what National Science Foundation charges every engineering research center with, and these 4 components to do convergent research, which really means highly interdisciplinary research, engineering workforce development, so develop the workforce of the future in these emerging technical fields, diversity and culture of inclusion, so to create an inclusive environment that brings additional strength and diversity into our engineering solutions, and also the innovation ecosystem, so to create that tight collaboration, allow for tech transfer with industry. And Dimitro Pakilko, who you're going to hear from later, heads that up for us. So that's a core obvious connection for this innovation summit. But just to show that everything is woven together in a well-functioning engineering research center, and that is that this Innovation Summit and the programming, as you'll see, we're highlighting the convergent research because we need to demonstrate the feasibility of our research. That's also the workforce development. You're going to see a lot of presentations from our students after this first year and a half of their work, and so they'll be showcasing their research so you can get an idea of what they're working on. And also the diversity and culture of inclusion connections that we need to clearly listen to our key stakeholders. And so that's government, industry, and community. So just a review of the agenda that you all have. We're going to start by a keynote from Jumbi Edulbehram from NVIDIA, and that's following with a chat from Jorge Ortiz, who leads that Research Thrust 5. Then we'll have a panel discussion on privacy, security, in smart streetscape technology. Take a little break, and then come back, and you'll see we have mixed up the program with some competitive elements as well. So the students will be doing a pitch session, and you will all get to vote on those. So these are the student pitches, and so we'll have 2 blocks of 5. These are rapid fire pitches. And then some lightning talks from the faculty from the center. So we'll have 4 faculty give short lightning talks and a brief moderated discussion following that. Then lunchtime and a poster session from some more of our students. And I'm happy that we were able to get students from all of our partner institutions here, so thank you. Then we'll turn to the accelerator demo day, and Dimitro Pakilko will explain this, but we've had a tech accelerator running over this past semester where teams of students and faculty have been getting training in order to be able to realize their ideas and how that would look and bring them to market. So they will have their own competition, so you can hear from them. Take another break, another pitch session, and then finally a panel discussion on urban test beds. And they will be joined with some leaders from the city, West Palm Beach, New York City, as well as some urban designers as well, to find out how those test bed pilots can drive innovation. And then we will wrap. So with that, I want to highlight a few special thank yous. So for our founding industry advisory board members, so NEC Corporation, who are represented here today, these are a big thank you to them. So these are the founding industry members. HOK is a global design, architecture, and engineering planning firm. And Grid Matrix, they're a cloud-based software platform for traffic engineers. And also we have several key government partners. And so New York State has been a big supporter through the NISTAR program. This is the Empire State Development Division of Science, Technology, and Innovation. The U.S. Army Research Lab, also a big supporter. And New York City, so we've been engaged with numerous departments in New York City, Office of Tech and Innovation. You'll hear from Paul Rothman later in the day. The Department of Transportation, the Office of Public Safety, and the Economic Development Corporation of New York City. And finally, the city of West Palm Beach has been an outstanding supporter of this work, and particularly the test bed down in the city of West Palm Beach. And finally, and I know that Dimitro will recognize them later, but I just wanted to make a special mention as well to all the mentors that participated in the accelerator program that are listed here. So thank you again very, very much. We deeply appreciate your help. So with that, I wanted to turn to the keynote that we have. So we're delighted to welcome Jumbi Edulbehram from NVIDIA. Jumbi oversees the global business development for smart cities and spaces at NVIDIA, and is responsible for driving the adoption of AI solutions for spatial intelligence. So Jumbi, I realize this, there's going to be followed by a moderated discussion with Jorge Ortiz from Rutgers University. Jorge is in Department of Computer Science and leads our Research Thrust 5. That's the integration research thrust and building the applications for us. And as I was looking over their bios, I noticed something that I think they didn't notice themselves, which is they're both actually Berkeley PhD grads. So Jumbi in city and regional planning, and Jorge in computer science. And so this is, I guess, a kind of a California reunion for them, even though they never met at Berkeley. So without further ado, I just want to welcome Jumbi to the stage, and we need to do one little technical transfer here.
Perfect. Yeah. Well, that's good. Center mode. Excellent. Well, thank you very much, Andrew. And yeah, thanks for inviting me. Really honored to be here. So as Andrew mentioned, I'm in charge of a business at NVIDIA that we call Smart Cities and Spaces. And so we work with cities, states, public agencies, and large spaces such as airports, seaports, and stadiums. And as the subtitle shows, in our business, I like to think of AI as assistive intelligence because, as I'll show you, and I have about 10 slides, so I'm not going to PowerPoint you guys to death, but a lot of the applications are based on real data to have real outcomes and affect people's lives. So this is the only NVIDIA slide, so you'll have to excuse me. But the reason I popped it in is to show you that AI these days is used in pretty much every industry you can imagine, from healthcare to autonomous vehicles to even quantum physics. Digital twins are a very interesting application. And of course, smart cities and spaces. But even everyday applications, like for example, when you get recommended songs on Spotify or videos on YouTube, are based on crunching a large amount of data using AI. So, just to sort of simplify the sort of big universe of AI, for our business, these are really the three types of AI that are relevant, right? Perception, simulation, and generation. So perception is based on collecting information from a large number of sensors and making sense of that information. And these sensors are used to detect, classify, and segment things, for example, that a camera sees in a scene. Simulation is used to create, if you will, a metaverse or a digital representation of the real world. And it's used in a variety of interesting applications, like I'll show you. And then generation is a relatively new kind of AI that's used to generate text, images, videos, and also make sense of those and translate them into natural language. So I'm just going to give you some examples, right? So these are examples. Let me see if these things actually work. Where's my mouse? Oh, shoot, I don't have my mouse here. One sec. Let me... There we go. So, these are just some examples of a company that does near-miss detection. So this is a near-miss for a pedestrian. So this is a near-miss for a person on a skateboard. This is a near-miss for a person on a bicycle. So, once you collect information on these kinds of scenarios and you kind of understand how they happen, then you can instrument the real world to make sure things like these don't happen. For example, this is a simple example for instrumenting a crosswalk that automatically detects a pedestrian and then make sure the vehicles stop in time so something like you saw here in the upper left doesn't happen. Then I'm going to show you in the next few slides, just again, a smattering of examples from, why is this not? Partner companies that we have that utilize our AI technology. This, for example, is a company called Blue City, or Velodyne now, that instruments intersections with LiDAR. So they pick up a lot of information on different modes of transport, vehicles, bicyclists, pedestrians, and then do some real advanced safety analytics. The next example is actually from a company called No Traffic, and in fact, one of the execs from No Traffic, Chris, is in the audience if you have questions on this. But they actually instrument lights to reduce congestion. So this is an example of a street in Tucson, Arizona, where they've actually instrumented a large number of intersections, but this just shows the results from one of those intersections where analysis of traffic patterns can be used to dramatically reduce congestion, right? And of course, reducing congestion means cars stop at lights for less amount of time, which has a major environmental impact. And in fact, you can even enhance safety. And in fact, I was talking to Chris just before this presentation, and he mentioned that near misses and accidents have gone down by 30%. Just another example, and in fact, this one is being used in New York City by a partner called Automatus. They use computer vision to actually figure out what's going on the sidewalks and the curbs, right? So they analyze vehicle movement, the types of vehicles, how long they stop, etc. And based on this analysis, they can even actually do micro charges so that city can actually generate revenue. Talking about simulation, simulation based on synthetic data has become absolutely critical for AI these days. And the reason is, if you want to train AI, it's practically impossible to collect real-world data for the millions of different scenarios that you can encounter. So synthetic data bridges the gap between sort of the real world and the sort of metaverse, if you will, to train AI by creating massively large data sets. Gartner predicts that by 2030, a majority of the data used to train AI will be synthetic. So this is an example, created by a partner of ours called Deloitte. In fact, I don't know if you know, but there's a huge intersection safety challenge put out by the US DOT. And of the hundreds of companies that applied, they've narrowed it down now to 15 solutions. And this is one of them. And in fact, a lot of AI that is being trained for this solution is being trained using synthetic data. So this is a very simple example. The next one I'm going to show you is something that we actually use and created at NVIDIA to actually train autonomous vehicles. And as you can imagine, this is one of the most difficult AI problems in the world today, because an autonomous vehicle needs to be able to deal with just literally millions of things that it can encounter in the real world. So to train it, you have to create all those scenarios in different types of weather, in different types of sensors that can be used to collect the information, and the sensors that cars have, different road conditions. And I'll fast forward this, for example, emergency management situations, etc. So all these are created synthetically to actually train the autonomous vehicles. So talking about generation, cities, public agencies in general have a massive amounts of data, right? And based on the sensory data I showed you, based on synthetic data, once you've collected a massive amount of data, you need to make that data accessible. So RAG stands for Retrieval Augmented Generation, which is, think of it as a smaller version of a massive large language model like ChatGPT, which basically collects all the information that it can possibly get from the internet. RAGs are based on a constrained amount of information, so they don't, what they call hallucinate as much, as in they don't make up stuff that they don't know, right? So RAGs will only give you information that you've actually put into the database. So pretty much every department in the city or a state agency, public agencies, have some application for these RAGs these days. And interesting application for RAGs are chatbots or avatars to enable easy access to this information. So how many of you guys have used, for example, if you're in the city, My City chatbot, actually in New York City? Okay. It's fairly new, it's early stages, but it can be used to access actually an incredible data set of publicly available data in the city. The one on the left is actually an implementation in Amarillo, Texas, where they have this really cool avatar which answers questions that you ask it just in natural language. And now with AI, you can actually do automatic translation. So you can actually ask it in any one of those languages. There's actually a pull-down menu. So this makes these data much more accessible to a diverse population, especially in a place like New York City. The one on the bottom left is actually one from Coral Gables, which is still in beta, but it actually encompasses not just information that the city collects, but information about the city. So you can ask it about, restaurants, best ways to bike from point A to point B, whatever you want. So that's it. Like I said, short and sweet. So we have. Very good. So I should get off this.
Sit down. So thank you very much, Jumbi. So I'm going to welcome to the stage then for our fireside chat without the fire. Jorge Ortiz, as I mentioned, professor from Rutgers in electrical and computer engineering, and he leads our Research Thrust 5. So take it away, gentlemen. I think you just push the button.
Great. It's very exciting to be here, and that was a wonderful opening talk. So in the Streetscape, in this project, we're looking at, I think one of the unique aspects of the project is the amount of convergence of not just the technological innovation, but also the aspect of the community. What do you think are some of the biggest challenges? Is NVIDIA thinking about the way that the technology is being deployed in the street and the way in which it's being perceived and interacted with the citizens?
Yeah, that's a great question. So, a couple of different aspects, right? One is data collection, right? So there are a lot of sensors that collect data, and you've got to make sure that data collection is done in a way that, doesn't violate, for example, privacy. And, so sensors like, for example, LiDAR that completely anonymize all objects, are useful for something like that. And then, of course, once you've collected the data, you've got to ensure the data is used responsibly. And, again, that is a couple of different aspects. One is you've got to make sure that, the data doesn't go, and this is just in data in general, not just for AI, goes to the right people at the right time and being used for the right purposes. But once you sort of put what we call in AI these guardrails around how data are collected and used, then I think, again, like a lot of technology, there are pros and cons, but what I find in our business is that overwhelmingly, the applications around, safety, congestion reduction, curbside management, et cetera, have such a positive impact that, people have now gotten to a point where they can actually see real impact in the real world, improving lives. And that, just makes a big difference.
Absolutely with all of that. I think one of the things that I saw from your slides of the separation between perception, generation, and simulation. Mm-hmm. Many times for, when technologies are actually deployed, we have to do some cross-cutting work across those three. In fact, I'm biased in that front, being in the applications front, thinking very specifically about how to draw those bridges between those pieces. What do you think are some of the big technical challenges with being able to build those bridges and enable, certainly on the data collection side, there are issues with what data, from whom, how often, how much is it, how much computation. On the simulation side, getting enough representational diversity in the data itself to simulate the real world as closely as possible. And on the generation side, it seems like generation is still early on, certainly on the language model side. But in some cases, our systems, certainly when we put them out on the street, are going to have to touch all three of these. What do you think might be some of the challenges ahead as far as doing that?
Yeah, that's a big question. So, talking about sort of synthetic data in particular, what we found is that, there are sort of a few different use cases, right? One is, of course, visualization, which, as Andrew said, there are applications like wayfinding, et cetera, around, a city like New York could be incredibly valuable. And then, of course, I think in terms of sort of citizen participation, collaboration, once you've got a visualization and collaboration on, and citizen involvement in the different scenarios that you can very easily create and imagine, in the synthetic world, is super useful. And in fact, generation is now being used to create these scenarios. So for example, if you want to create different kinds of buildings, you can say, create a 10-story tower, with these dimensions, and boom, you've got a picture which you can easily put into the synthetic world. So previously, in terms of technical challenges, creating the kind of, synthetic metaverse that I showed you, for example, when the car was driving around a city with different conditions and stuff, used to be very tedious because it was done by hand. So you'd have to actually create, CAD drawings and put it into the metaverse. Now with generation, you can actually generate all these digital assets very quickly to use in the synthetic world. So it's become a lot easier. I don't know if is there an aspect of your question that I didn't address?
No, for sure. I think those are some of the right ways. At least to me, sound right in terms of, generation for generating more diverse data sets. The other aspect I think that is sometimes a bit overlooked is, in many of the examples that you provided, and this is something that we constantly ask ourselves, is that we're creating technology that's certainly pushing the boundaries in our individual areas of discipline. But the question, comes back to the citizens and and the various stakeholders, right? So it's both the people who live in the location plus the companies and government that has other interests that are not necessarily in opposition to what the citizens want, but finding that sort of sweet spot is a challenge. Mm-hmm. And I would say that one of the big challenges that we deal with here, and perhaps with NVIDIA you have a much broader perspective on this, is how you, first of all, discover what the objectives are of the various players, and then how you sort of find that sweet spot of having impact, not just an economic impact for a company or a business, but also on actually improving the quality of life of the citizens that are there. How have you seen, are there any quality of life observations that you've made through the various applications that NVIDIA has worked in?
Sure. Maybe I'll use a really controversial one to answer your question. Facial recognition, right? This is something that, when you even mention it, people are like, oh, privacy, they're gonna take my face and do all kinds of things with it. But to give you a real life example, the first time it was used in a stadium, Cleveland Brown Stadium, for access control. So when you buy a ticket, you're given the option of, using your face, registering it, so when you walk to the stadium, you can actually just walk through because they've already recognized who you are, they attach your face to the ticket. So the first year that they implemented it, there was about 20 to 30% compliance. But the line for obviously people that needed to be scanned was about 5 times as long for people walking through. The next year, there was 90% compliance. So, there's an obvious benefit that people can see in the real world of something that, people obviously use on their phones and stuff, but to your point, implementing these technologies in the real world, there is sometimes, reticence or whatever. But when people actually see the real world impact, curbside management is another example. People say, oh, there's going to be cameras in the curbside, they're going to see, cars driving up, blah, blah. But when actually store owners in the curbside see what a massive impact it's had on the amount of congestion, double pricing, double parking, et cetera, that it has, their perception changes pretty quick. And what we also find is you can actually synthetically demonstrate these impacts, right? So for example, actually in an airport, we did a simulation of what if there was 5,000 more people in this terminal and there's an incident and people need to evacuate quickly. How long is it going to take, right? So when you show people the real impact of, even if there's an incident, it's fine, there's a safe space because you can actually get out in time. Let us show you. So,
Yeah, I think those are all great. I feel like especially I could relate to that one. Although the sports one. Although I do think on the flip side here in New York with the Knicks, we know that the owner of the Knicks used it to kick people out who had spoken poorly about him. So it's a double-edged sword. Although certainly I think in many of these situations there's an immediate benefit. But speaking of looking at the flip side, maybe thinking about the failure cases, what of all the different companies that NVIDIA has worked with from your experience, where do you see are the common pitfalls? What are the things that we as a sensor perhaps should be looking out for as we deploy these technologies and engage with the community, engage with businesses? What do you think are things, or what are some maybe even specific examples that you can talk about where something failed and there was a good lesson to be learned from that?
Yeah, that's a good question. So I think the key thing in a lot of these initiatives, especially which involve technology instrumented in the public realm, having public input and full transparency right at the beginning of the process, as opposed to after the fact, is absolutely key. I was recently at a meeting where they had pretty much everyone across agencies in Alameda County in California. And there was about 100 people, and everyone from law enforcement, emergency management, to other city workers, accounting, everyone was there. And then they broke up into groups to discuss the impact that AI was going to have. And, to your question, they sort of went through some of the past examples of where it hadn't really delivered on the promise, right? And figure out, okay, now going forward, let's make sure we sort of avoid those pitfalls. And a lot of those, in the end, I came to realize had to do with transparency of, technocrats going in and instrumenting certain solutions without necessarily having full transparency and participation of the stakeholders right in the beginning of the process, as opposed to just getting feedback at the end of the process, is absolutely key. And yeah, there are obviously examples where, there is pushback from the public. Like, for example, we were talking about, congestion pricing in New York, right? Once they implement congestion pricing, which some of you might not know is going to happen in June, beyond a certain point, you're going to get tolls. Now, the question is, how is that going to change behavior? And is that behavior change going to be, a positive impact? Or could it be, some kind of negative impact on traffic patterns, et cetera? And of course, they've done tons of studies to figure that out. But in reality, you'll only find out once it's instrumented and see what the real world impact is. So unfortunately, in a lot of cases, yes, you've got to wait till the solution is actually implemented and then figure out what the impacts are. But again, what's critical is to be completely transparent about the impacts that, potential impacts before it's instrumented, and then of course the real world impact, and then make the data available, right? Traffic patterns, congestion across the city, wait times and lights, etc. If you make all that data accessible, then people can judge.
So I'll turn to I guess more of the how do you deploy it question. In some cases, it's sort of a wholesale. We re-instrumented all of downtown. Something that I've observed happens in these situations is that the citizens and businesses and everyone else is kind of blindsided to it. I think with congestion pricing, there's been a discussion of congestion pricing for a long time, and then they're doing a wholesale implementation, or releasing this thing. So the sensors are already there and it's ready to go. Are there other ways in which deployments could maybe organically expand, or maybe you could partition it into phases? Because one of the things that happens when you do it wholesale is it's much harder to obtain the trust you need to keep it in place. And I think what citizens are concerned with is that there's no turning back once it's out. I wonder, of the deployments that you've seen, have you seen some that have gone out in phases and you've seen a maybe better, more adoption, if you will, rather than the wholesale deployment strategy?
No, that's absolutely critical. I would say that should be a requirement for every kind of public deployment of technology, which is to instrument it on a much smaller scale, actually have processes and resources and people in place to be able to measure the impact. Like, for example, that example I gave of no traffic, they literally did one major street that I was showing in those videos. They actually measured wait times, safety impacts, all that stuff. And once that was there, now they're up to like 30, 35 intersections across the region, and can actually instrument intelligence at a regional level, which has a major impact, and then demonstrate, for example, that emergency management vehicles or law enforcement can actually safely get from point A to point B, right? As opposed to now where they're going through red lights, they're blasting their things. So there's a more intelligent way of doing it, but critical to actually demonstrate that on a much smaller scale. Another example is at airports a few years ago, and again, this hasn't been even rolled out to all the airports. They started the automatic lane where they, again, do some facial recognition. You can walk through, you pre-registered, blah, blah. They started it at 1 or 2 airports, saw the impacts that it had on the lines of the airport. And then, all the airports in the US, at least as opposed to other countries where they're owned by the same entity. In the US, like for example at JFK, every terminal is operated by a different entity. So you have to demonstrate to them the positive impact before they're convinced to start deploying. Yeah, that's a great point.
So actually, just to add to that question, since you've seen all of these deployments and these methodologies for doing the deployment, both on the deployment side and on the specific applications, have you seen approaches that generalize well, you think, across US cities? So for instance, oftentimes we ask ourselves if a technology as deployed in a place like Arizona would fit the complexity of an urban landscape like the one that we can see right outside our window, right? And so it's always that sort of question of what of this generalizes, and how do we decide how to deploy it, what technology to deploy, and what the technical challenges are that come with that?
Yeah, no, that's a great question. Actually, the good news is that a lot of the technologies that I showed and a lot of sort of even more advanced technologies for smart cities have been implemented global cities much more so than in the US. The bad news is the US is a little bit behind, but if you look at cities like Singapore, Tokyo, Seoul, and a bunch of even European cities, Amsterdam, etc., they've actually implemented a lot of these solutions. So, cities in the US would do well to sort of find a more representative city globally where, this technology has been implemented. So for example, yes, New York City's congestion pricing. Congestion pricing has been done in London for, a decade, right? But it is a different city because it's circular, there are sort of rings that are used for congestion. Here's, one long strip. So there are differences, obviously. But to the extent that we can, we should look out, see the cities, the airports, the stadiums, seaports that have implemented some of these technologies and see what the impact has been.
That's interesting. So, I also ask myself as we brainstorm on the different applications that we're trying to build, is some of it is technological and engineering, and some of it is design. To what extent, and something we don't actually talk about that explicitly, of how much the engineering and design need to go together. And side note, I just saw something last night where in Hong Kong, they realized from their cameras that they could not get people to look up while they were looking at their phone as they were crossing the street. So they redesigned many of these streets to have the light flash from the floor. Right? Not a high-tech solution, but effective.
That's right.
What other aspects like this can we see? Because we see a lot of the generation. We know that that's computationally expensive. It's like super high-tech. All the sensing is super high-tech. But sometimes it's just, no, put the light here. Right? I sort of wonder how to mix those two as we think about the future of city applications.
No, that's a great point. And this is going to become super relevant right now if we become more accepting of autonomous vehicles, right? So a lot of autonomous vehicle companies are thinking about how to make vehicles operate safely in the real world, but we need to start thinking about how to instrument the real world to make it safer for autonomous vehicles. Like, for example, you're a really great example. Another example is signal lights, right? Autonomous vehicles don't need signal lights. They were put there for people learning how to drive in the 20s and 30s so they could see a big, red or green light right in front of them. All autonomous vehicles need is a little sensor on the road that tells them to stop, right? So rethinking the infrastructure as these new technologies are being implemented, super critical. And to your point, I don't think we're actually doing enough of that right now in the US, where it is difficult because, again, for better or for worse, there's a sort of public forums. Infrastructure changes are a lot tougher in, our system than they are in some other systems. Instrumenting technology in some ways is a lot easier. But to your point, to think holistically about, the infrastructure changes needed as the technology is being implemented, absolutely critical. And like I said, with autonomy right now, like they're finding, for example, in San Francisco, where you have autonomous Waymos that will pick you up, drop you off with no driver. When you first go in there, it's a little spooky, I gotta admit. But again, the roads, as they realize, the roads, the curbs, the light infrastructure, etc., are not really designed for the vehicles. They're trying to operate in an infrastructure that was designed completely for another purpose. So yeah, super critical.
This is great. I think that notion of, so I think that brings up a sort of broader issue of the fact that streetscapes are also a place where high technology that doesn't have all of the, so it can have all the sensing, it can make all the decisions, but it's fundamentally interacting with people in environments made for people historically. And you often find situations where, for instance, speaking of self-driving cars, the car comes to a stop. It's following the rule to a T. It must wait 3 seconds. It's in San Francisco, high traffic area. People keep crossing. It never gets past the stop sign. We learn while we're driving to send out a social cue, even through this moving object, to kind of inch forward and say, hey, I'd like to go. If you're a pedestrian, you make eye contact with the driver to kind of nod and agree. That goes away with a self-driving car and makes things quite challenging. And I can imagine that in the interface between humans and these AI-driven systems, we have to do a lot of thinking much more carefully about what those social cues are. Driving in Manhattan is very driving from driving in New Jersey, very different from driving in Queens, right? Very different from driving in Arizona. And I'm curious how much in your experience at NVIDIA, folks have at least noticed that this is an upcoming issue, right? Like, I think it's actually quite fundamental in having any autonomous system interact with people, particularly in streets. That's absolutely going to be a fundamental question and building block where we're going to have to design some solutions.
Yeah, no, great point. So I think the great thing about AI in general, as opposed to some of the older, machine learning techniques and stuff, is that it learns, right? So let's say you've instrumented an autonomous vehicle that's actually learning from driver behavior. And you notice that, in New York, if you want to turn right, when you've got the right and people are crossing, you've got to have, the social cues. You inch forward, whatever, right? And, AI systems learn from that. And we learn from the AI learning about behavior. So, for example, when you're turning, maybe you want to start flashing some light to indicate, the autonomous vehicle that the autonomous vehicle is ready to turn. Again, the real world is super, super complicated place, right? And even every intersection in Manhattan is a little bit different, right? Some are very large, some are very small, some allow you to turn, some have a lot of people crossing, etc. And again, like I said, the great thing is AI actually learns. So it can actually learn the design, the structure, the patterns, everything, and then hopefully get better.
That's great. Yeah, we're very excited about tackling those problems as well. So we have only a few minutes left, and I'll open it up to a couple of questions.
Hi, I'm Patrick Arasi. I'm Professor Smith's previous student, and I currently work at Meta in the Generative AI department. Great talk, thank you for that. I'm curious, what do you think about the next hype would be? So currently the hype is about generative AI. Do you have an opinion about what is the next hype going to be in terms of AI? Thanks.
Oh, wow. That's a tough one. I think, generative AI right now is being used primarily for natural language, right? Everything is based on these large language models. I think the next wave is going to be applications for generative AI for a lot of other fields. So, for example, for drug discovery, for even architecture, for literally you look across the board at a lot of these different industries and different application and use cases. I think the next big wave is going to be applications of generative AI in all of those, as opposed to just for the large language models, kind of the chatbot kinds of applications. And I think the other, for me at least, super interesting and exciting area is a language translation. This is kind of the holy grail, right? Just imagine being able to make phone calls, interacting with someone in completely a different language, using whatever the hell language you want. And in fact, I was a couple of weeks ago at a security show, and there were companies they operate 911 call centers. So imagine someone calling 911, they're not a native English speaker, and they speak, say, Slovenian, right? Even for the person on the other side to recognize what the hell language they're speaking, and then to find someone who speaks that language, by the time you find someone who recognizes the language that's being spoken, the person's probably in a lot of trouble, right? So even applications like that, where you can immediately recognize different languages, interact, with the person for especially critical, management situations, is I think going to be the next wave of really interesting AI applications.
We can take another question. One more question.
I came in late, I apologize. My particular interest is computer vision with inexpensive single board computers. Okay, what do you think about the future of that? Is that the way things will be? And also one day I envision a device maybe about the size of one of these notebooks, which you point at a roadway and it'll tell you basically everything that's going to go on that roadway, whether a squirrel crosses it, what kind of vehicle goes by. Have you seen, it's just not, all the technologies are there, they're just not integrated into an inexpensive device yet. Where do you see that technology going to keep on bringing down the price for a single board computer vision device?
Yeah, now you're talking my language. Yes, no, absolutely. So, there are two sort of technology trends, and they're in general sort of, I'd say, two philosophies of processing in general. So one technology trend is, there are more and more intelligent, if you will, computer models for recognizing what's happening in the real world and sensing, right? So previously, we used to sort of pre-program everything to recognize certain objects, to segment certain objects, etc. You're going to get to a point where, kind of like a large language model, you have a large, visual model, which will pretty much recognize everything that's going on in the scene automatically. That you can, like you said, put a cheap camera and then go and ask it whatever questions, right? How many cars went by, or how many red Honda Civics went by, whatever you want. The other trend is, of course, computing power is massively increasing. So in fact, the small edge device that NVIDIA makes a few years ago was too expensive and not enough power to put in an edge device to actually do what they call inferencing. So, AI is two parts, right? You're going to train the models, and then you're going to do the inferencing where it makes decisions. And now it's possible to put some pretty advanced inferencing, to your point, right at the edge, right? So now in terms of the two philosophies of where you should put it, it really depends on the use case. I mean, there are use cases where it makes sense to inference at the edge because you require, say, massively low latency. You want to quickly change the light, or you want to flash something to prevent the pedestrian from crossing, or you want to signal to an autonomous vehicle, whatever, right? Low latency applications, you definitely want at the edge. Other philosophy is for super advanced applications which don't necessarily require super latency, you might want to run them in the cloud. But depending on the data, if you're collecting massive amounts of high-def video, you don't necessarily want to send everything to the cloud because you may not have enough bandwidth. So it's a trade-off. Does that answer your question?
Yes, thank you.
Great. So with that, we'll conclude the Fireside Chat. It was a pleasure chatting with you, Jumbi. Yeah, absolutely. Thank you. That was a pleasure.
Thanks again, Jumbi and Jorge. Thank you very much.